All right, so that's the preliminaries. Now, I'm going to talk today about a techno-social initiative called Open Agentic Knowledge Stack, and that derives from open source and community together. I think we're kind of a little bit... Yes, all right, yeah. So I'm also the founder of Premium AI Communities in Bay Area. I run Bay Area AI. I founded it more than 20 years ago. So this is the longest running, deepest technical AI meetup in the world. And I also founded the conference called AI by the Bay. We're running for 11th year this November in Oakland, California. And you're very welcome to check us out and join us in November. Next thing. All right, so about me, I think I mentioned a lot of things about myself already, so we can skip that. So, you know, we've seen AI, generative AI revolution being described everywhere, right? So I stumbled upon this fun product on eBay. This is a H100 handbag. You can actually buy it for about $1,000. It's not the real H100. You cannot plug it out and plug it into your data stack. But you know, this is indicative, right, of what is going on right now at in the AI space. So you've seen multiple talks in this conference, right? So you see some infra talks, you see model talks, you see application talks. The problem for many business users is how do you put it all together? It's very difficult to orient yourself in this landscape, right? So we have quickly emerging industries, and they're driven by demand. So, you know, folks who train models, they throw a bunch of money on them, so there is a lot of VC investment. So that leads to the development of inference frameworks and setups very quickly, right? So you see kind of skewed development where we have huge bulge in the models, huge investment in the models, right? But it's an arms race. It's a kind of a bit artificial because small percentage of increase in performance in the model does not necessarily translate in improvements in applications. So it's hard for somebody who is an applied architect in an existing company whose job it is to translate their business knowledge to an AI app. It's hard for them to place themselves in a landscape. So the motivation for this architecture we describe called OAKS is one of them is to provide a landscape, a map, where open source contributors can place themselves. So first of all, right, you kind of should articulate, if you're working in this space, what it is that you're doing, right? And you also should articulate how you relate to others. And I think we're very well doing the first part. Everybody, of course, likes to talk about themselves and what they're working on. But I think it's very important, if you're an open source, to understand how do you relate to other participants, and also where are you on the stack, right? Are you at the infra stack? Are you at the model stack? A lot of people are kind of hybrid. They do multiple things. If you provide the UI-driven agentic framework, where are you? How do you get the knowledge into this framework? Right, and I think it's very important for all of us to kind of work together. So one of the goals of this collaborative project is to give a framework where we can all kind of place different components of open source AI. So why is this of interest to Neo4j, and why is it actually a good way to approach AI applications? Because think of this, kind of step back and ask a question, what do you want to achieve building an AI application, right? A lot of people are just doing it because it's the hype, because your boss told you, how do we plug in AI into our system? You know, every company has to have an AI strategy, but the actual question, if you're a scientist, if you're an engineer, what do you actually want to achieve, right? So it's amazing how many questions, right, how many kind of directions this question can clarify. And so any kind of senior computer scientist I work with always at some point ask this question, right? You know, you're kind of a graduate student, you're a PhD student, you come to your advisor, you're a new engineer at Amazon, you know, I come to kind of some kind of, you know, director of DevOps, and I'm explaining I want to build this and that, and they says like, what do you really want to achieve, right? So the question I think in AI is we want to encapsulate AI knowledge that your business has. right? So if you look at any business, why is this business successful? For instance, Coca-Cola, why is this a successful company? Coca-Cola is not a successful company because they make a soda, right? There is a million different other sodas. You can get addicted to one or the other. Coca-Cola became very successful because of the logistics of distribution, right? And so they actually were propelled to global scale by US Army, which had bases around the world and ordered a lot of Coca-Cola. And so they had to actually figure out how to distribute it globally. So they have a network of global distributors, right, and producers. So every company has expertise, usually, like an airline knows how to move people very effectively from one geography to the other. And usually national airline knows best how to operate in the capital and so forth. But you have to be good at something. You have to have some knowledge about the world that lets you run a successful business. And AI does not replace this. AI can only help you encapsulate this in an application. So you have to think, what is the knowledge which I'm capturing? It's not the mechanics, right? Agents are just functions. You have to think, what is it that I want to put in the agents, and how do I basically convey this knowledge? How do I make this knowledge actionable to an agent? So at Neo4j, we're building knowledge graphs for almost 20 years, and the industry goes back decades. And all the machinery that semantic web community developed, that NLP community developed, it's amazingly coming back, right? So we know how to structure knowledge and how to represent it separately from, LLMs. And so LLM itself is not a repository of knowledge. LLM is just a giant hash. LLM hallucinates, right? It's a way to index and store data. But you need a way to represent ground truth if you want to verify that LLM is not hallucinating. So this is why I think knowledge graphs and graph RAG are emerging as the answer to how to build reliable business application, which first encapsulate business knowledge, and second, allow you to dehallucinate LLMs. Next, please. All right, so here is how we kind of think of this flow of knowledge through an AI application. So at some point we have structured input. We take a bunch of unstructured data and we represent it in certain organized way. So I'm a big fan of strongly typed functional languages such as Haskell, OAKS, Scala, and Clojure, and so forth. So they have a very well thought out type systems. Python used to be less capable, but now fortunately we have Pydantic, which is basically a type system for Python. And Pydantic was adopted by majority of GenAI Python applications. So I'm very happy that we kind of we can do this across the languages. But generally, you need to extract your data and think of this as knowledge and represent it in a structured format. So, for instance, Dockling is a project for my former IBM colleagues, which extracts structure of a PDF as a semantic map, right? So it represents it as Markdown, and so it's not just text, right? It's not just style. If you think of PDF as structured data, you can now have a hierarchical representation in tables and captions and chapters as kind of levels, right? So you should think of your data as effectively knowledge, right? And you should represent it semantically. So this is the first step. Think of this. Every parsing, every database extraction leads to now some kind of knowledge encapsulated in a data structure. You do not lose it. You do not reparse it. Once you extracted it, you only enrich it, and it always remains validated. Right? If you have some knowledge, you should be sure that this is actual knowledge which remains, right? Because the biggest problem in LLMs, you don't know what's true, what's not. So if you spend time, you extract the data from a SQL database, usually SQL database is a transactional database of some kind of business transaction, so user data. So you believe that this is correct. And so once you do this, you should structure all the processes in such a way that they do not lose the invariant, that the data in this record is correct. So then you move this knowledge through the system, through transformations, right? You just not willy-nilly replace fields. You should think of every transformation working on this structure as an atomic transformation. You can add fields to it, but then you need to add fields to all of the records of this kind, right? So the very basic data processing approaches which ensure that your knowledge stays correct. And finally, when it's time to act on this knowledge, so your agent decided, right, to do something, and they actuate this knowledge, they can, for instance, produce a structured output. That's a very typical result, right? So you have this agentic system which needs to do a lot of processing and give you back some kind of report. So if it does this report, structured output is the approach that basically says, fill this data record with fields. The fields should be of the correct type, and also they should be some semantic invariant. For instance, a receipt must have itemized items and subtotals and taxes and totals, and they all should add up to correct numbers, right? So you have effectively constraints. And so structured output recently became a very important part of almost any GenAI system. So Llama added structured output. Gemini has structured output, and a company called .txt, which has wonderful French co-founders. This is a very successful product called Outlines. It's open source structured output product, so I highly recommend. Right, so generally, so let's think of kind of knowledge flowing through an AI application, and let's think of all the open source contributors who work on different parts, right? So we have Docklin here, we have Pydantic throughout, we have .txt, we have a Llama. So if you think of kind of what is the outline of my architecture of knowledge flowing through an application, then you can place different open source companies along this line, and then you can evaluate what they do in a more rigorous fashion, right? So there is some structure emerging here. Next, please. So we propose this architecture for agentic knowledge and memory called OAKS, right? So just to reiterate, so we have structured input, we have transformation of knowledge, which is rigorous and valid, and the Bayes invariant. We have actuation, which is based on the stage of the structured knowledge, but we also have AI memory, right? So this is one component we need, because all these agents, they effectively enrich their knowledge of the world, and they need to store it somewhere. So AI memory very natively emerged in the last few months, because once people start thinking about agents, they needed to think, how do we exchange the information, and how do we actually kind of enrich the common worldview among these agents, right? You need to synchronize the memory. And so it's very interesting, because at Neo4j, we have a knowledge graph, which is actually the most kind of obvious and reliable and well-known way to represent agentic memory. You can work on different parts of knowledge graph in parallel or sequentially, right? So different agents can touch different nodes. You can have nodes representing people. If you learn something about people, you can enrich those nodes. You can have transactions, you can have relationships, you can enrich the edges, which represent connections between the nodes and the interactions, right? So in Neo4j model, you can store random information in either a node or in a relationship, right? And so agents can refer to this knowledge, they can enrich it, they can decorate, they can add records to various nodes or relationships. But there are different other ways to represent AI memory. There is a company called Cogni, which interoperates with 30 different systems and frameworks and kind of provides a unified view of agentic memory. LangChain recently added LangMem, which is their own way to represent AI memory for LangGraph agents. So if you look at any agentic framework, they will have some kind of AI memory. So one take home here is that usually it's some kind of a knowledge graph, right? Because you need to represent facts, you need to represent their relationships, you also need to represent some kind of temporal sequence in which this knowledge was acquired. So this can all be done in the knowledge graph. Next, please. So Neo4j participates in the AI Alliance and Linux Foundation for AI Data. So we started this project called Agent and Server Knowledge Graph, called ESG. So we're in the design stage right now. We work with some pioneers of knowledge graphs and MCP. And so the idea is that we have all these MCP servers, and you've seen in previous talks, there are basically giant directories of MCP servers, like Glama has 5,000 servers, or MCP.so. But if you look at this, it's just like a little square, and it just generally tells you about the MCP server. The problem with that is, first of all, we don't know what does the server do. There's no easy way to figure out even what its parameters are and what its purpose, what is this domain for the server. right? So you cannot really automatically compose it. The problem with MCP servers right now, if you come from functional programming background, is that they're not composable. So I just want to ask you, like, who can program in any kind of functional language, like Haskell, Clojure, Erlang, Rust, any of this? All right, everyone knows. Okay, at least one. So the beauty of this, functional programming basically teaches you that your program is a composition of functions, right? So the input of one function is the output of the other function, and so the types should match. That's the beauty of type system. If you compose a bunch of functions with types, the compiler checks that they all match, you have a data pipeline. The problem with MCP server, it's not even a REST API. It has inputs whose type are specified, but the outputs are not. And if you look at this, it's very weird. If you're any kind of developer, you always know that a function returns some kind of a type. So why would they not do this in MCP? And the reason is that LLM is very flexible, right? LLM can do whatever you want. So you can say, here's my inputs, here's a list of names. Now give me a beautiful graph of these names, right? Like key value pairs. Sort them by numbers, sort them by keys. Give me a pie chart, give me a table, right? Give me top 10. So the output of an LLM request is actually very flexible. So that prevents MCP spec, I think, right now from imposing an output type. However, you can probably consider multiple data workflows in a typical usage of an MCP server. And you can ask, what is the typical use of this tool, right? Like the typical use of this chart, it's a bar chart or a pie chart. And so you can basically create several specifications of the typical MCP output for the server. And if you do that, then you can create composable call chains. So one of the purposes of our project is to basically elicit these typical pattern usages and invite people to think of composing these calls, right? And that can be done basically with a lot of information. So if you have the public knowledge graph describing MCP servers in detail, and it's also machine readable and human readable, then we can let all kind of automatic software engineering AI tools create composable chains of MCP calls. Next, please. So the format which we're going to use is called semantic croissant, and it's a new machine learning data format which was defined by Google and collaborators, and it's hosted at ML Commons. ML Commons is a nonprofit hosting MLPerf, which is performance benchmark for clouds, and ML Commons is also part of AI Alliance. So they emerge as kind of a very good repository of data and formats. So croissant is essentially a giant JSON-LD schema describing data file format, right? So if you have this huge data sets of machine learning, machines need to thoroughly understand what is in every field, and so that's what it does. However, semantic croissant is an extension to the croissant, which is led by folks at the Royal Dutch Academy of Sciences, and it's an EU project, effectively. So they have the project called Dataverse. Who here familiar with Dataverse? So Dataverse is, 800,000 data sets publicly available through European collaborations. And there is a data server at Harvard. So it's a pretty interesting framework. So croissant is used to describe the data sets. However, you need to describe the ontologies of, right? You need an ontology to understand what is this data set about, right? So croissant does not address this directly. Semantic croissant offers effectively a hierarchical series of servers which hold ontologies for domains. So you can basically ask questions like, who is the authority on ontology for automotive industry? And hopefully, BMW and Tesla and others will get together and build this ontology if it's not there already. And then you can consult their server and say, give me the definitive ontology for a car, for electric car, for a truck, right? Electric system, hydraulic system, engine. What are the standardized names for components of a cylinder? And so usually they exist in the industry, right? So somebody should be responsible to maintain this ontology. So semantic croissant purpose is to be that ontology authority. And so we realized that actually this is what we need for MCP servers, because MCP servers operate in the world, right? Somebody will operate an MCP server for automotive industry. It has to talk the language of automotive industry. It has to return the normalized names of components in a car, not some random things you came up with, right? If you want to order some part from a supplier, you need to know exactly what it's called. So adding semantic croissant and hierarchical ontologies to our AskG project will allow us to characterize these MCP servers in standardized industry terms across any kind of industries. So that will allow business users to quickly find what MCP servers exist for their domain, what do they do, and if they add value or not, and then you can actually decide that I want to pay for this MCP server, right, because it does something useful to me. So that's the purpose of standards, right, or open standards. Next, please. So that's a little bit more about semantic croissant. So, the beauty of having the ontologies and control vocabularies let you do your graph rag generation much better, right? Because the terms that come back will be standardized and is distributed. Next, please. So what we're doing with our OAKS project, right? We're basically building a community where we invite folks. You don't have to, do much here. Like, you can come and just list yourself. We started as a Notion workspace. So you'll see my contacts at the last slide. So the way to engage right now to reach me or some other folks, entry points. So first you can just go and look what's here already and add yourself, right? Describe what you do. The next step is to map, if you have MCP servers, right, as we build this specification and themselves to the knowledge graph, right? And as we define this composability, it will be very interesting to invite people basically to say, you have an MCP server, what do you think is the compatible and reasonable set of MCP servers other people use with yours, right? It kind of lets people interact and think, where am I in this chain of open source AI, right? And then you can build composable flows. So the users who will use this knowledge graph using either manual or AI tools, right? They will then come up with sequences of MCP servers and agents. So this is not limited to MCP. We start with MCP as A2A matures, as ACP from IBM and others matures. We can add, obviously, nodes represented agents, right? So this is not limited. So the question is, what are the composable AI tools, right? And so as users start composing them and call chains together, build workflows with them, we can then present this knowledge as recommendations. Here's a typical workflow. Here's a best practice that you can use from extraction to actuation. Next, please. So this is, I'd like to mention, right, this is the conference which we run in San Francisco Bay Area for 11 years. It happens at this majestic Masonic temple in Oakland. If you're not, you haven't seen it, you will be impressed. And it's November 18 and 19. So we welcome folks to partner with us, to sponsor, to speak. And that's the URL for that conference. Next, please. And so basically that's it. So I don't know, we have some time for questions, right? So my colleague Ivan will bring the mic to you. If you have a question, please raise your hand. And meanwhile, I'll have these contacts here. So if you want to learn more about the OAKS, feel free to email me. I have a community email, I have Neo4j email, we have a blog, I have a Medium, so all of this stuff is there. Yes, please.
Hi, question. Thank you, very interesting. It's actually we are looking for this API, MCP, it's a big step to share the knowledge on building the component system routine. But it's perfect work, but we are living on not perfect work.
Yes.
You see that API is done by developer and documented by developer. Documentation is not so bad. The developer is loved too much, So another problem is that when an API is documented by developers, it's technical information, not functional information, not knowledge information. But we are needing to share with the MCP, with the agent to put in the hand user. When you ask question, never ask question about how is your API. You ask question how operate API. It's something, right?
Yes.
So how do you see and when you see usually see kind of problem?
So thank you. You just made a case for OAKS, right? You just motivated why we need this. So we need a knowledge graph of MCP servers, which are not useful to developers only, right? It should be enriched. So basically, the entry in the knowledge graph should be everything which MCP specification requires, which, as you said, is just a functional API definition. Here are the types of the input. It doesn't really have it. So semantic croissant will add an ontology entry. So this server is about for instance, people, right? Like it gives you personal information. This server gives you, certain business information. So we can add links to more data. So when you do graph rag extraction with AI, it will now have a lot of context. So when you feed your context to AI tools, through this, through semantic croissant and the enter in the knowledge graph, you suddenly will get much more very specific and enriched context. For instance, you can say this server operates with this vocabulary, right? Because it's in the automotive industry. So now you know that your queries will be related to that, right? Like if it's one of your businesses operating in a domain, and there is a domain ontology for this, you suddenly will have much more terms, right? So, and what we also want to do is we want to force people, or entice people, to describe much more, right? And so it's very simple, because if you, like, we will probably just put a very basic description, which we'll just copy from you. And if your developer didn't bother to document it properly, right, it will be limited, and then users of the system will complain, and they say, this guy has much better definition, and this is very basic, I don't know how to use it. So I think we'll create an additional motivation, right, for folks producing these servers to come and document it better.
Exactly, so you're totally right. You see as the point, the key point now, the documentation is unbuttoned as well as the code,
Yes, absolutely. So we hope that will help.
My question is like, it's kind of a general question is, when you start an AI project, right, nowadays you often choose a large language model. When should we use large graph over large language model when we start a project? In which cases, in general cases, we should try to use large graph over large language model, or how we position them to work together. So if you use large graph and you use large language model, which role they should
yes. So so they're not one or the other, right? So basically, an LLM is effectively a runtime. You can think of this as a runtime, right? A knowledge base, is kind of a graph program, a state machine, right? So I think the best way to explain this is called graph rag. And so Neo4j was doing this for years, but last year Microsoft built its own team, published its own project called graph rag. And so the term took, right? It's not Microsoft trademark, it's a general term. So now almost every provider, for instance, Amazon has their own graph rag on Amazon Neptune, which is their graph representation, right? And every graph provider usually provides some kind of a graph rag. So graph rag is a retrieval with a graph. And so the typical pattern works, you put your proprietary knowledge in a database. So with rag, a vector rag, you just drop it into a vector database, like VV8, Pinecone, and Melvus. And so with Neo4j, you put it in Neo4j, which can also do everything a vector rag can do, right? So the pattern is the same. So you basically, you have your query, so the space is embeddings, you represent your queries in embedding, you query the database, you get some enriched context, and then you feed it to the LLM. So the workflow is the same. However, with GraphRag, there is a next step, right? There is a window to retrieval, because now, so let's say you have several nodes which match your query, right? In vector space, they're just dots in multidimensional space, which is fine. So you can have these dots, and you can just rank them, you can look at them, but you cannot do much with them. You can take top 10 of them, which are closest. There is not much more. However, in the GraphRag pattern, each node is a graph node. They have links. For instance, they have links to their summaries. Each node can be a chunk, but each chunk can link to the summary of the document. It can link to an ontology, right? It can link to an address. It can link to a person. So now before you further process it, you can look at these nodes and do whatever you want. For instance, for Chinese market, I can look, are they related to China? And I can re-rank them because Chinese customers want something else. There are some words that I don't want to use. Similar for Europe, similar for US. So because you have this rich structure of your proprietary data, right, you can construct the context for the LLM much better. So, but the architecture is generally the same.
Thank you.
Mm-hmm. All right, well, there is no questions. Thank you very much.